Hello and welcome to OCube, an organization building open source solutions for data intelligence. Today, we're continuing our series of videos explaining how to build a Databricks Lakehouse using infrastructure as code with Laktory, the all-in-one solution for defining both data transformations and Databricks resources. If Terraform, Databricks Asset Bundles, and dbt had a child, it would probably be called Laktory. In this episode, we build job workflows and explore how to leverage Laktory, Pipeline's framework for managing data transformations. But before we do, if you want to ramp up your data and AI engineering game, make sure to like and subscribe. Before jumping right in, let's have a look at the big picture. In this architecture diagram, we have all the main components typically found in a Databricks Lakehouse, from users management to pipeline jobs. Before watching this third episode on job workflows, make sure to watch previous episodes linked in the description. We start where we left things off after the Workspace episode. As you might recall, we previously set up directories to store notebooks and other resources, and we also created clusters that will be used to test our data pipelines. Today, we'll dive into building workflows, starting with a simple hello world example and progressing to a more complex, multi-hop data processing pipeline. First, we run the quick start and select the workflows template. The stack shows that we'll be deploying the file containing stock prices for our data pipeline job. Additionally, we'll need a few supporting notebooks. However, for now, we'll comment out pipeline jobs and focus solely on deploying the hello job. Let's go ahead and get that deployed. In the Workspace, we can now see the hello job is available. The notebook used in this job is straightforward, printing hello Laktory, while we start the job and wait for it to finish. Let's take a moment to review its configuration. It specifies the type of cluster to be used and the tasks to execute, which reference the notebook we just reviewed. Additionally, Laktory simplifies setting permissions directly within the job definition, allowing you to easily define who can view, run, or manage the job. Now that we have covered a classic notebook-based job, let's have a look on how Laktory can help to define a pipeline job. We will use the pipeline shift with the quick start, but modify a few things. Unless you are planning on running the pipeline locally, an orchestrator must be selected and configured directly into the pipeline definition. Databricks Job and Delta Live tables are currently supported. Defining a Laktory pipeline boils down to creating a collection of nodes, each one defined by a source, a sink, and some transformations. Multiple types of sources and sinks are supported, from disk file path to data table and pipeline node. In the stock prices bronze table, the source is the JSON data file deployed in the same stack. But a more common scenario would be files on a volume. For the sink, we write into a table from the default catalog using an overwrite method. For the silver table, the source is the bronze node. This direct reference to other nodes is what allows automatic DAG creation and orchestration of tasks. The sink is again a data table. The interesting part is the transformer, a chain of transformations that be declared as SQL statements, Spark DataFrame functions or custom functions in this case. The first transformation is simply a SQL select statement in which a special notation is used to reference the data frame output from the previous node. The next transformation uses Spark's drop duplicates method on the timestamp and symbol columns. This is equivalent to writing the PySpark code. That applies this method to the output of the previous node. Now that our pipeline is defined, let's go ahead and deploy it. Since we selected Databricks Jobs as the orchestrator, the pipeline will be deployed as a job, and all the necessary tasks will be automatically created. As you can see, each node or table is created in the context of a single task, and the interdependencies between tasks is set already. All tasks are linked to the same generic notebook, After setting up configuration widgets and installing the required libraries, the pipeline object is instantiated by reading its configuration file, which has also been deployed to the workspace. From there, it's as simple as calling the execute method on the node targeted by each task. One of Laktory's standout features is the ability to develop and debug your pipeline directly from your IDE. You can set up a script that reads the local definition of your pipeline and executes it using a Spark session, allowing for rapid iteration without needing to deploy anything. This debugging script is included in the Quick Start. Just provide a cluster ID, select your pipeline, and run the script. The logs describes how the pipeline is executed, listing read, transform, and write operations for each node. Upon completion, you can even examine the output data frame of any of the nodes. Before executing the pipeline as a job on Databricks, we will remove the cluster specification to adopt a serverless configuration. We are all set now. Let's hit that run button. Now that the execution is complete, let's take a quick look at the Hive Metastore to confirm that the expected tables have been created, and it looks like everything is in order. Creating a 2-nodes pipelines is a great start, but let's see how to build a more realistic scenario involving joins. Using stocks metadata, we will create a second set of bronze and silver tables and finally a join between the two. The data for the second set is deployed as a JSON file in dbfs. In the pipeline, we add the new nodes. Starting with the bronze table, we read from the JSON data file. The silver table reads from the bronze node. It also uses a special function allowing to drop all source columns. The transformer makes use of the with columns to create new column using a Spark-like syntax. Finally, the silver stocks table is created by joining the meta and stock prices data. The join is defined using a standard SQL statement, but instead of referencing table names directly, we refer to the output of the previous transformer node and another pipeline node. After defining the join, we also create a new column using a date truncation function. Before deploying, let's test everything locally by running the debug script. Success! The output data frame shows that the results are exactly as expected. Another great feature of Laktory is the ability to visualize your pipeline stack. This representation allows you to inspect the data flow between nodes and verify that everything is functioning as expected. Heading back to Databricks, we can see that our job has been updated with new tasks reflecting the additional nodes. Now, let's go ahead and run the pipeline. Exploring the Hive Metastore confirms that all the expected tables have been created, and the silver stocks table has the correct schema as expected. That wraps up our demo on building a lakehouse as code with Laktory. From basic notebook-driven job to full-fledged, configuration-based data pipelines, you are now equipped to generate value from your data. Hopefully, you found it straightforward to declare and deploy data pipelines. In the next episode, we'll look into how we can redeploy the same data pipeline as a Delta Live table by simply changing the orchestrator. Make sure to subscribe to the channel so you're notified when it goes live. Have you tried deploying data pipelines as code before? How was your experience? Share your thoughts in the comments below, and we'll see you next time.